Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of PC, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about preemptive multitasking under the priority-based scheduling algorithm. So, preemptive. So, multi means more than one. Task means some. Means the artists do the multiple tasks. At a time, only one task. Since its execution time is less than in microseconds, end user can't have the role. It seems to be parallel execution. It seems to be. Preemptive execution means if any new process enter into the ready state, the currently executing task is temporarily suspended and compare the priority of the currently executing task with the newly entered task. Okay. Here priority means here we are defining 0 is the highest priority or 0 is the lowest priority. Based on that, which priority algorithm we need to follow. Highest priority or lowest priority. Based on that, we can schedule the process. Which process needs to be executed currently or first. Okay. Let us take one example. So here considering three processes: P1, P2, P3. With estimated completion time 10 milliseconds, 5 milliseconds, and 7 milliseconds. Respectively, enters the ready queue together with the priorities 0, 3, 2. Okay. A new process P4 with estimated time 2 milliseconds with priority 1 enters the ready queue after 2 milliseconds. Okay, after completion of 2 milliseconds execution, a new process is entered. So assume all the process contains only CPU operations. No IO operations. So 0 is the highest priority, 3 is the lowest priority. So here we consider okay. So three processes P1, P2, P3 with estimated time 10, 5, 7 milliseconds and the priorities 0, 3. A new process P4 with completion time 2 milliseconds, priority 1 After 2 milliseconds of execution, it is entered into the ready state. Shortcut we have written. So now we can go for that. So first, at the time of 0, what are the processes available in the ready state? P1, P2, P3. So as per scheduling algorithm, that is priority based. So among these three, which process is having highest priority? So since 0 is the highest priority here, so we are scheduling P1 first. P1 is scheduled first. Since it is preemptive multitasking, if any new process enter into the ready state, immediately suspend the currently executing task temporarily and compare the currently executing task parameter, that is here priority, with the new process priority. So among them, which one is highest priority? That is scheduled first. So at the time of 2 milliseconds, P4 enter into the ready state. So P4 priority is 1, P1 priority is 0. So among these two, P1 is having the highest priority. So P1 execution is continuous. So this execution time is 10 milliseconds. Okay. Okay. The scheduler checks the ready state at the time of 10th millisecond. So P1 is entered into the running state. At the time of 10th millisecond, its execution completed. Enter into the completed state. Next, 10th millisecond time, we will check the ready state. The scheduler checks the ready state. What are the processes available in the ready state? P2, P3, P4. Among these three, which process is having highest priority? So P4 is having highest priority. That is one. So that is scheduled first. P4. P4 execution time is 2 milliseconds. So 12 millisecond, its execution completed. So P4 enter into the running state, it execution completed. P4 completed. Next, what are the processes available in the ready state? P2, P3. Among them, which one is having highest priority? P3 is having highest priority. P3 is having highest. So its execution time is 7 milliseconds. That is 12 plus 7, 90. So P3 enter into the running state. Again, it enter into the completed state. Next, at the time of 19th millisecond, what are the processes available in the ready state? Only P2 is available. So P2 is scheduled for execution. P2 is entered into the running state. P2 entered into the running state. Okay. Next, what is its execution time? P2 5 milliseconds. Means 24th millisecond. Its execution is complete. Okay. Like that, all processes scheduled and their execution is complete. Now, we can calculate the waiting time and turnaround time for each process. Waiting time means how much time the process is waiting in the ready state. Turnaround time means how much time the process will take to complete its execution from entering into the ready state. So first, waiting time for process P1. P1 enter into the ready state at the time of 0 and its execution completed at the time of 10th millisecond. Sorry, it's the scheduled for execution at the time of 0 itself. So it is waiting time is 0 milliseconds. Waiting time for P2. P2 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 19th millisecond. Okay. So how much time it is waiting in the ready state? 19 milliseconds. Okay. Next. Waiting time for P3. P3 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 12th millisecond. So how much time it is waiting? 12 milliseconds. Okay. P4. Process P4 enter into the ready state at the time of 2nd millisecond and it is scheduled for execution at the time of 10th millisecond. So P4 is waiting in the ready state up to 8 milliseconds. So average waiting time in this requirement is sum of all the individual waiting times by individual total number of processes. So the average waiting time for each process in this requirement is 9.75 milliseconds. Now turn around time for process P1 means the time taken by the process P1 to complete its execution from entering into the ready state. So P1 is entered into the ready state at the time of 0 and its execution is completed at the time of 10th millisecond. So total time is 10 milliseconds. Next. Turnaround time for process P2. P2 enter into the ready state at the time of 0 and its execution is completed at the time of 24 milliseconds. Okay. So total time duration is 24 milliseconds. Next. Turnaround time for process P3. So process P3 enter into the ready state at the time of 0 and its execution is completed at the time of 19th millisecond. So total time is 19 milliseconds. Turnaround time process P4. Process P4 enter into the ready state at the time of 2nd millisecond and its execution is completed at the time of 12th millisecond. The total time duration is 10 milliseconds. 12 minus 2. Okay. So the average turnaround time for this requirement equal to individual sum of individual turnaround times by the total number of processes. That is equal to milliseconds. That is equal to 15.75 milliseconds. So that is so like this we can check average waiting time and average turnaround time for this requirement. The average waiting time is 9.75 milliseconds. Average turnaround time is 15.75 for this requirement. Okay. In the same manner, we can check average waiting time and average turnaround time for different scheduling algorithms for this requirement and decide which scheduling algorithm is best suitable for this one. Okay. For this topic, we can refer. The textbook is Introduction to Embedded Systems by Shibu KV, and publisher is Tata Mega. The edition is second, published in 2000. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.